A nice quick video here for you today, folks. We're looking again at our right angle triangles. This time we're looking to find an unknown angle. We'll be using many of the skills that we practiced in the previous video. We'll be making sure we can label our right triangles using opposite, adjacent, and hypotenuse. We'll make sure we can choose a trig ratio, that is our sine, cosine, or tangent. We'll be making sure we can work down, and we'll be making sure we're comfortable using our calculator to calculate a trigonometric ratio, and we will go through that here in this video as well. So we'll jump right in. Without further ado, we'll jump into the first example. We'll find the measure of the angle. So that is, we have ourselves a right triangle. We can see this indicated in the corner here. We know two of the side lengths. Those side lengths, hang on, here's our right triangle directly across from that. You know what, folks, maybe pause the video here, try and label this triangle on your own and identify which trig ratio we'll be using, sine, cosine, or tangent. I am about to go through this here. So directly opposite our right angle, we always have our hypotenuse. Directly opposite our angle that we're trying to find, we have our opposite side. So that leaves beside, adjacent to the angle that we're working with, we have our adjacent side, but there's no information on the adjacent side that we have here. We know our opposite side length, we know our hypotenuse. Those will be what we're using. Because of that, we know we have SOH CAH TOA, and we'll be working for the ratio that does not rely on our adjacent side. That's going to be our sine ratio. So we know we're working with our sine ratio. That is, we're working with the sine of theta. We'll just leave it as a theta here because it's an unknown side. Sorry, it's an unknown angle. The sine of theta equals our opposite over our adjacent. And so we will substitute now into this equation the values that we know. We don't know theta. Again, we leave it as is. We do know our opposite side. That is 8 centimeters. We know our adjacent side. That's 15 centimeters. Nice and easy. Then all I'm looking to do is divide my 8 centimeters by my 15 centimeters. I know how to do that. Just throw that right into a calculator. 8 divided by 15, nice and easy. Nice and easy. I'm working with 0.533. And again, I'm working with the sine of theta. Here I'm using my working down skills right here. If you're confused by this, make sure you brush up on those skills. If the sine of theta equals 0.533, remember, I'm looking here trying to find my unknown angle, that theta value. I can find that theta value by using what we call our inverse sine function. That really what it does is it will undo this sine function. So these are going to cancel out. Not yet, they're going to cancel out. If I use my inverse sine function on the left-hand side, I need to use my inverse sine function on the right-hand side. Now they cancel out on the left. I have remaining just theta on the left-hand side. And on the right, this funny piece just says the inverse sine of 0.533. So we throw that right into our calculator. 0.533 is already here. And then I'm using my trig functions. I need to make sure I hit this. If I hit this second button, this will turn my sine into an inverse sine button. I can click that and it tells me it's 32.2 degrees. Easy. So if that's the case, theta equals 32.2 degrees. That is my unknown. That's my unknown angle that I set out to find in the first place. Not so difficult. What I encourage you to do here, number one, double check that your calculator gives you this number. If it does not, it's probably in a different mode. If it gives you a different number here, it's in a different mode, and you'll need to Google how to set that into degrees instead of radians. Question B here, same thing. They have given us a right triangle. They're looking to find an unknown angle. I want you to pause the video, use all of the skills we just practiced. I want you to try it out, see if you can handle it, because in 3 seconds we'll be going through it together here. Good, so we know opposite our right angle is our hypotenuse. We know opposite the angle we're working with is our opposite side, and we know adjacent to that side is our adjacent. Easy. Now, if that's the case, we know our opposite side length, we know our adjacent side length, we do not know our hypotenuse. So when we're using our SOH CAH TOA, we need a ratio that does not have hypotenuse. That means sine and cosine are out, tan is in. So we're working here with the tangent of theta equals my opposite side over my adjacent side. Easy. Now I'm substituting in the values I know. Opposite side is 15.5 kilometers. My adjacent side is 11 kilometers. I'm still working with the tangent of theta. I throw that into a calculator. 15.5 over 11. 15.5 over 11. Nice and easy. And that's, when I say over, that's dividing, right? So 15.5 divided by 11, 1.409. That's what I'll be working with, 1.409. And again, because I know where this is going, I'm going to move this over, 1.409. I have the tangent of theta. It's my goal to get this theta isolated. In order to do that, I need to get rid of my tan. The opposite of tan is the inverse tan. So tan, and then with a superscript -1 right up here. And I'll do that because I did it to the left. I'll do it to the right. They cancel out on the left. I'm left with theta equals the inverse tan of 1.409. I can use my trig functions here. Second, to get an inverse here, the inverse tan of 1.409 is 54.6 degrees. So that's what I'm working with right here. Oops. 54.6 degrees. Nice job, us. Now you know how to use your SOH CAH TOA in the other direction to find not just an unknown side length, but an angle as well. Nice work.